You are welcome to online lectures with Pharmaceutical the School Board. Today, we'll take a look at pharmaceutical calculations. We'll start from where we stopped yesterday with solving problems sent by my students on pharmaceutical calculation. Okay, question number 1. Okay, the first question for today is taken from Introduction to Pharmaceutical Calculations by Judith A. Rees, Ian Smith, and Jenny Watson, 4th edition. Page 210, Practice Calculations, page 210, question 13. Let me copy the question on the board so we can take it off from there. Okay, the question says zinc sulfate 0.25%, this should be weight in volume. 0.25% weight in volume eye drops are required to be made isotonic with sodium chloride. Full stop. What weight of sodium chloride is required in the preparation of 100 ml of eye drop solution? A 0.25 weight in volume percentage weight in volume solution of zinc sulfate depresses the freezing point of water by 0.022 degrees Celsius. Okay, this question wants us to make a zinc sulfate preparation for eye drops, 0.25% weight in volume. The question wants us to make that preparation isotonic. This may be a scenario in manufacturing firm where they are done they want to produce eye drop, ophthalmic drop of zinc sulfate 0.25%, but they want to make it isotonic with sodium chloride. They now want us to calculate the amount of sodium chloride required to make this isotonic. Now, for us to do that, what we need to do is to, first of all, look at this zinc sulfate. This 0.25% weight in volume zinc sulfate is certain as saying 0.25 gram of zinc sulfate in 100 ml. So 0.25 gram of zinc sulfate in what? 100 ml. So that's the meaning. But this solution on its own causes freezing point depression of what? 0.022 degrees Celsius. For this solution to be isotonic, it should cause a freezing point depression of water of 0.52 degrees Celsius. That means it should be able to depress the freezing point of water by 0.52 degrees Celsius. But this solution on its own, 0.25%, can only depress by 0.022 degrees Celsius. There's a problem. That's why it's not isotonic. In fact, it's not isotonic. So what do we do to make this what? Isotonic. We need to add sodium chloride. And how do we now determine the amount of sodium chloride we need to add? First of all, we should be able to find out the further depression required for this to depress up to 0.52 degrees Celsius. So we need to determine the further depression we need. And to determine this further depression we need, we subtract the depression that should make it isotonic, which is, we subtract this freezing point depression from the depression that should make this isotonic. And that depression that should make this isotonic is what? 0.52 degrees Celsius. So if we subtract 0.022 degrees Celsius from 0.52 degrees Celsius, we get a particular freezing point depression. Now we now look at the amount of sodium chloride that can cause that depression we got, the difference. And that one is simple to get. Since we know that 0.9 gram in 100 ml, that is 0.9% weight in volume of sodium chloride, can cause freezing depression of 0.52 degrees Celsius. We now say, okay, how many percent of this sodium chloride can cause this difference we got? If we get that percentage of sodium chloride that can cause that further depression, we now find out the amount of sodium chloride in that strength. That will give us the amount of sodium chloride, the weight of sodium chloride we need to make this solution isotonic. So this is just a summary of what we need to do in this question. Let's take it off from there. Solution. First of all, we look at the strengths. The zinc sulfate is 0.25% weight in volume. And the same 0.25% weight in volume can cause this 0.022 degrees Celsius depression. So 0.25% weight in volume zinc what? Sulfate causes what? Causes what? 0.022 degrees Celsius what? Freezing point depression. But we need freezing point depression of what? 0.52 degrees Celsius for this solution to be what? Isotonic. What do we now do? So to be able to do something, we need to get the further depression we need. So further depression needed is equal to what? 0.52 degrees Celsius minus 0.022 degrees Celsius. 0.52 degrees Celsius minus 0.22 degrees what? Celsius. That's the freezing point depression further depression we need for this solution to be what? Isotonic. For this solution to be what? Isotonic. Excuse me. So, if that is the case, we now have 0.52 minus 0.022. I don't want us to waste time. So 0.498. So we have 0.498 degrees Celsius. This is the further depression we need to make this solution, this zinc sulfate, this 0.25% weight in volume zinc sulfate, isotonic. Zinc sulfate cannot do anything again, so we need to add sodium chloride to be able to achieve this. And if you add how do we now know the amount of sodium chloride we need to add to make this isotonic? We know as a standard that 0.9% weight in volume of sodium chloride cause freezing point depression of what? 0.52 degrees Celsius. Now, how many percent of sodium chloride solution can cause this depression? So 0.9% weight in volume sodium chloride cause freezing point depression of what? 0.52 degrees Celsius. Therefore, X percentage weight in volume of sodium chloride solution will cause freezing point depression of what? 0.498 degrees Celsius. Let's find this X. X is now equal to what? 0.9% weight in volume times 0.498 degrees Celsius all over 0.52 degrees Celsius. So if we cancel out, we have something like this. We have 0.9 times 0.498 divided by 0.52, 0.862, 0. What? We have, so S is 0. What? S is what? 0.862% weight in volume. So 0.862% weight in volume of sodium chloride is what can cause this further depression. But this is just a strength, percentage. It's a strength, it's concentration. We need to calculate the weight of sodium chloride that can cause this what? That can cause this depression. So if we open up this now, this 0.862% weight in volume is certain as saying 0.862 gram of sodium chloride in 100 ml. That's the meaning. Meaning of this 0.862% weight in volume is 0.862 gram of sodium chloride in 100 ml. Before we can do anything here, we need to check the volume of the preparation. The volume of the preparation is what? 100 ml. So everything is in order. We don't need to do any convert any conversion here. This is 0.862 gram of sodium chloride in 100 ml. And the preparation is also 100 ml. So the answer is what? Simply what? 0.862 gram of sodium chloride. So you need to add what? Because it says what weight of sodium chloride is required in preparation of what? 100 ml of the eye drop. So simply say 0.862 gram of what? Of what? Sodium chloride is what? Required to do what? Is required in the what? Preparation of 100 ml of what? Eye drop solution. So the answer to the question is what? 0.862 gram of what? Sodium chloride. That's what we need. I don't know if there's any question. If you have any question, please feel free to drop it or simply call this number. Better. Simply immediately call this number. Any of these numbers. Call any of these numbers. Call any of these numbers immediately as we discuss. If you have any question, call any of these numbers. I will attend to you right now because we are live. All right, we have 2 minutes to do that. Please ask your question if you have any. Ask your question if you have any. Okay. While we wait for questions, please, I want to make 1 or 2 announcements. Please, on weekly basis, specifically every Saturday, 7 a.m. to 7:10 a.m., I organize academic competition. I titled Academic Battle with Pharmaceutical Schoolboy. The registration is completely free of charge. All you need to do is to chat me up on WhatsApp. I will send you the registration link. And there are prizes to be won. The competition for the coming Saturday will be December 9th, 2023 is Pharmacology Battle 2.0. Pharmacology Battle 2.0. Follow me in all my social media platforms. You will see the flyers there. On Facebook is there. My Facebook name is Pharmaceutical the Schoolboy. On YouTube is also there. My YouTube name is Pharmaceutical the Schoolboy. On Instagram, Twitter, TikTok is the flyer is there. My handle username is @Pharmaceutical83. You can also check it up and chat me up on WhatsApp. I can also send the flyers and the link. I I encourage you to participate in this weekly academic competition. It will help you to improve academically. Please share this information with your friends, with your colleagues, with your children, and all your students, all your contacts. You'll be happy, and they'll be happy to get such information from you. So because the battle is free of charge, we depend on donation from people. So if you are inspired, you can donate. No matter any amount of money you donate, we go a long way motivating our youths to pursuing academic excellence. That's the goal. And God will bless you as you do so. Please comment on these videos, subscribe to my YouTube channel for more live lectures from 3 to 4:30 a.m. every day. We are live. If we are live, giving us values, giving you values. If you have any question, we're about to end this class. If you have any question, please feel free to send your questions on these numbers via WhatsApp. Okay, stay tuned. Don't go, because we'll be back. We'll be back in a few minutes' time to continue with more questions, because these questions come from different students. So as we solve, we go on and off. This is what we keep doing until it's time to end the class. All right, see you then. See you then. The time is 3:26 at exactly 3:40. I will be live again. We'll continue from where we stopped. God bless you.